Okay, so get this. We're diving into AI mathletes today.
Yeah.
But not just like any mathletes. We're talking Olympiad-level stuff.
Yeah.
The kind that would make, like, even Einstein reach for a calculator.
Yeah.
You sent over some articles about this, and let me tell you, this stuff is next-level cool.
It really is remarkable how far AI has come in mathematics. Like, we've reached a point where these models, they can actually outperform humans on certain benchmarks.
It's amazing to me. I remember when AI struggled with, like, basic multiplication.
Yeah.
And now they're out here, like, wrestling with equations I didn't even know existed.
Exactly.
But you know what's even wilder? The articles that you shared pointed out that these AI brainiacs are starting to find existing math tests.
Yeah.
A little, well, pedestrian.
It's true.
Yeah.
Like, imagine giving a calculus exam to somebody who's already mastered, you know, advanced calculus.
Right.
It wouldn't be a real challenge. And that's where Omni-MATH comes in.
Omni-MATH?
Yeah.
It sounds like something straight out of, like, a sci-fi movie. So what is it exactly? Is it like some kind of ultimate AI math showdown?
You could say that. It's this new benchmark designed specifically to test the limits of AI's mathematical abilities.
Okay.
We're talking 4,428 Olympiad-level math problems.
Whoa. 4,420. Okay, now you're speaking my language.
Okay.
But just to be clear, we're not talking about your average high school algebra.
Right. Not even close. These problems come from some of the most prestigious international math competitions, like the International Mathematical Olympiad, or IMO, as it's known.
Okay.
And the Putnam competition.
Wow.
These competitions are designed to challenge like the sharpest minds in mathematics.
So we're talking serious brain-bending stuff.
Absolutely.
And they just, like, threw all these problems at an AI.
Well, not exactly. Omni-MATH is organized in a very specific way.
Okay.
So first, it's broken down into more than 33 different subdomains of mathematics.
The 33 different areas of math.
33 different areas of math.
So everything from, like, the basics.
Yeah.
Like algebra and geometry.
Yeah.
To, what is it like? Advanced theoretical calculus and, don't tell me, non-Euclidean geometry.
You got it.
Oh, wow.
Though non-Euclidean geometry is anything but basic.
Right.
It explores geometries beyond our everyday understanding of space.
Right.
But you're right, Omni-MATH covers it all, and it gets even more interesting when you consider how they ranked the difficulty of all these problems.
Okay, now you've got my attention.
Yeah.
How do you even begin to rank the difficulty of an Olympiad-level math problem?
It's a tall order, but the researchers found a clever solution.
Okay.
They turned to a fantastic resource, the Art of Problem Solving website, or AOPS.
AOPS.
There you go.
Legendary online space for math whizzes.
Yes.
I spent some time on their forums back in the day, trying to wrap my head around calculus.
Well, it turns out AOPS has this well-established system for ranking problem difficulty, and the researchers use this existing system for many of the Omni-MATH problems.
Okay, that makes sense.
Yeah.
But what about the problems that weren't already rated on AOPS? Did they just have to guess?
That's where it gets really interesting. Remember GPT-4, the advanced language model we talked about earlier?
Yeah.
The researchers actually used GPT-4 to assign difficulty levels to the remaining problems.
Hold on. So they used AI to figure out how hard other AI would find math problems.
Exactly.
That's some serious Inception-level stuff right there.
It really highlights the complexity of the task.
Yeah.
And it speaks to the fact that these Olympiad-level problems, they aren't just about number crunching. They require deep logical reasoning, creativity, and a knack for problem solving.
So it's not just about what these AI models know. It's about how they think.
Yep. Okay. I'm hooked. Now for the million-dollar question. How did the AI actually do on this massive math challenge? Did they ace it?
Yeah.
All right, the moment of truth. Did these AI Einsteins crack the code of Olympiad-level math?
Well, the results are fascinating, to say the least. The most advanced models, like OpenAI's O1 Mini, they achieved an accuracy rate of 60.54%.
Okay, so over half, right?
Yeah, that's got to count for something, right?
Yeah.
Especially considering we're talking about, like, the math equivalent of climbing Mount Everest.
It's certainly impressive. But remember, these Olympiad problems, they're designed to challenge the absolute best human mathematicians. So while 60% might be a decent score on a regular test, it's not exactly gold medal material in this arena.
Fair enough. But hey, nobody's perfect, right?
Right.
What about the other AI contenders? Any Cinderella stories in the mix?
Actually, yes. One of the most interesting findings was that some open source models, they actually outperformed GPT-4 on these Olympiad problems.
Oh, wait a minute. You're telling me that these underdog models, built collaboratively with open access code,
Yeah.
beat out some of the biggest names in the AI game? How is that even possible?
It seems that these open source models, they have a secret weapon, a broader training diet.
Oh, yeah.
They were trained on a wider range of mathematical data, which seems to have given them an edge in tackling, like the sheer variety and complexity of Omni-MATH.
So it's like the difference between training for a marathon on a treadmill and training out in the real world with all its hills and unexpected turns.
Exactly. Exposure to a more diverse landscape of mathematical problems seems to have given these open source models a significant advantage. But it wasn't just about overall performance. Researchers also discovered that even the most successful models, they had their academic strengths and weaknesses, just like human students.
Okay, so even AI has its favorite subjects. I have to admit, that makes me feel a tiny bit better about my own math skills.
Yeah.
So which areas of math did these AI whiz kids find easiest?
It turns out they excelled in areas like algebra, calculus, and number theory. These are often considered like the core areas of math. With well-defined rules and patterns, it seems the AI models were able to really internalize those patterns and apply them effectively.
Makes sense. Those are the areas with tons of data and examples to learn from. But you know what they say, if it were easy, everyone would do it. What about the subjects that trip these AI mathletes up?
Here's where it gets interesting. Across the board, the AI models struggled with what's known as discrete mathematics.
Discrete mathematics. You know, for our listeners who might not have this one memorized, myself included, what exactly does that cover?
It's a branch of math that deals with distinct separate values rather than continuous ranges. Think about things like combinations, graph theory. Remember those nodes and edges we talked about?
Yeah.
And even logic puzzles.
Okay.
Yeah.
I'm starting to see why that might be tricky for AI.
Yeah.
It seems less about applying formulas and more about, well, thinking outside the box.
Precisely. Discrete math problems often require a different kind of thinking, more about logic, strategy, and creative problem solving.
Right.
And it seems that the current training data for discrete math, it just isn't at the same level as other areas, which might explain why AI struggles with it.
So it's not just about crunching numbers. It's about understanding the rules of the game, so to speak. But going back to Omni-MATH for a sec, is it just about getting the right answer or wrong answer? Or is there more to it than that?
That's a brilliant question. And it gets to the heart of what makes Omni-MATH so valuable. It's not just a pass-fail exam. The researchers delve deeper, analyzing the types of errors the AI models made. And that's where things get even more revealing.
Okay, I'm on the edge of my seat. Spill the tea. What kind of errors were these AI geniuses making? Were they just forgetting to carry the one? Or was it something more fundamental?
You're going to be surprised to hear that most errors, they weren't simple calculation mistakes. It wasn't about getting the numbers wrong.
Yeah.
The AI models were stumbling over the logic of the problems, making reasoning errors.
So they had the tools, but didn't always know how to use them. Kind of like having a toolbox full of screwdrivers, when what you really need is a hammer.
A perfect analogy. They might have had all the formulas and techniques memorized, but they were still figuring out how to apply them strategically in these complex scenarios. And that, I think, is a crucial insight. It's not enough for AI to just know math. It needs to understand how to think mathematically.
Okay, now that is fascinating. But how do you even begin to teach an AI to think like a mathematician? Okay, I'm not going to lie, that's a bit of a head-scratcher.
Yeah.
How do you teach a machine to think like a mathematician? It's not like we can send them to math camp.
Well, maybe we can't send them to math camp yet. But you've hit on a key point. It's not enough for AI to just memorize formulas and crunch numbers. To truly excel at math, they need to grasp the underlying logic, the strategies, the creative problem-solving skills that human mathematicians use.
Right. So how do we get there? Is it just a matter of feeding them more data, more problems to solve?
That's part of it, but it's not that simple. Remember how we talked about the AI making logical leaps that weren't justified?
Yeah, like that whole, all dogs are mammals, all cats are mammals, therefore dogs are cats.
Exactly. To address that, researchers are digging deeper into those errors, trying to understand not just what the AI got wrong, but why.
So it's like those error analysis essays you had to write in school after a math test, only this time it's for AI.
Precisely. By analyzing those errors, researchers can identify patterns
Right.
and pinpoint areas where the AI's reasoning goes off track. That then guides them in developing new training methods and refining the AI's algorithms.
Okay, that makes sense.
Yeah.
But can we give our listeners like a real-world example?
Oh.
What does it look like when AI tries to show its work in a complex math problem and things go sideways?
Imagine an Olympiad problem that involves proving a theorem, a kind of mathematical statement that needs to be proven true. The AI might start off strong, correctly applying a known theorem, or manipulating an equation according to the rules. But then it might make an assumption, or a connection that isn't logically sound based on the problem's conditions. It's like arguing that if all squares are rectangles, and all rectangles have 4 sides, then all shapes with 4 sides must be squares. The individual statements might be true, but the conclusion doesn't logically follow.
Okay, I see how that kind of flawed reasoning could really throw off mathematical proof, even if the AI seems like it's on the right track at first.
Exactly, and that's why Omni-MATH is so valuable. It's not just about testing AI's ability to get the right answer. It's about understanding how they arrive at their answers and ensuring that their reasoning aligns with true mathematical principles.
So it's like teaching AI the difference between memorizing a recipe
Yeah.
and truly understanding the chemistry of baking. It's about nurturing those deeper cognitive skills.
Absolutely, and what's fascinating is that researchers are finding creative ways to do just that. One interesting discovery is the impact of something called data selection.
Data selection, is that like picking the best ingredients for your AI recipe?
It's a good way to think about it. Basically, they found that showing the AI harder problems during training can actually help it learn more effectively.
Wait, so giving the AI a tougher curriculum actually makes it smarter? It's like those teachers who give out extra credit problems that are harder than anything on the test.
Exactly. It seems counterintuitive. But exposing AI models to more challenging problems during training forces them to develop more sophisticated problem-solving strategies. They can't just rely on pattern recognition or memorization. They have to actually think critically and flex those logical muscles.
So it's like training for a marathon by running uphill on a treadmill all the time.
Uh-huh.
It might seem brutal, but it prepares you for the real deal.
Precisely. This data selection insight suggests that the key to unlocking AI's full mathematical potential might lie in challenging them, pushing them beyond their comfort zones, and encouraging them to develop truly robust problem-solving skills.
This is all starting to feel very humans versus machines, but in a good way. Like it's not about replacing human mathematicians, but pushing both sides to achieve even greater things.
It's a fascinating dynamic for sure. And it raises all sorts of questions about the future of AI and mathematics. Will we see AI proving complex theorems, making groundbreaking mathematical discoveries, maybe even collaborating with human mathematicians to solve some of the world's biggest mysteries?
Now that's a future I'm excited to see unfold. But for now, I guess it's safe to say that AI still has a thing or two to learn from us human math nerds.
Yeah.
They're on the right track, but they haven't quite cracked the code of true mathematical genius just yet.
Not quite yet, but maybe someday.
This has been incredible. Thanks for joining us for this incredible deep dive into the fascinating world of AI and Olympiad-level math.
Hey everyone, and welcome back. You know, I'm always up for a good brain teaser, something to really get those synapses firing. Well, today we're diving headfirst into the world of AI, but not just any AI. We're talking about AI taking on, get this, the Math Olympiad. You heard me right, the big leagues, where the world's sharpest mathematical minds battle it out. Turns out there's this new benchmark, Omni-MATH, and it's designed specifically to see if AI can truly reason like, a human mathematician. The catch, let's just say even the most advanced AI are still, well, hidden in the books. So walk me through this. AI is already composing music, writing code, even holding up its end of a conversation. But math at that Olympiad level, that's a whole different ballgame, right? What makes it so different?
It really boils down to the kind of reasoning involved. You see, AI, it's a pro at spotting patterns, following instructions. That makes it perfect for things like, say, chess or translating languages. But with higher level math, especially the kind they throw at you in those Olympiads, you need a deeper understanding. You got to grasp those abstract concepts, think outside the box, come up with solutions to problems nobody's even seen before.
So it's not just about knowing the formulas, it's about really getting the why behind them. I can relate to that. Back in school, I could memorize formulas all day long, but until that aha moment hit, until I understood the concept, I was toast. Is that kind of what we're seeing with AI and this Omni-MATH?
Exactly. That's precisely what Omni-MATH is designed to test, those deeper levels of understanding. And the results, Well, let's just say AI has got some serious studying to do. Even the most advanced models out there, they're only averaging about 50% accuracy on these Olympiad-level problems.
60%. Okay, so not failing, but definitely not bringing home the gold medal either. What's the breakdown? Where's AI shining and where's it, well, stumbling a bit?
Well, it seems AI, it's finding its groove with things like algebra, calculus, number theory, which honestly isn't all that surprising. Those areas, they've got mountains of data. And data, well, that's AI's bread and butter. But when you shift gears to something like discrete math, totally different ballgame.
Discrete math. Okay, for those of us who haven't cracked open a math textbook in a while, remind us, what exactly is that?
So discrete math, it's this branch of mathematics, right? It deals with separate, distinct values. Think whole numbers, graphs, logic puzzles. It's less about continuous change like you see in calculus, and more about analyzing relationships, structures, but in a more abstract way.
Gotcha. So if AI is like a student prepping for this big math showdown, discrete math, that's its Achilles heel.
Pretty much. But it's not just about the subject itself being tougher. Remember how we talked about AI needing that data, that massive amount of data? Well, when it comes to discrete math, that data, it's not as readily available.
So it's like trying to learn, I don't know, Mandarin or something. But instead of a dictionary and a grammar book, all you've got is like a tourist pamphlet.
Precisely. AI, it needs that rich, detailed data to truly thrive. And even then, there's still this hurdle, this challenge of truly understanding the why behind the math, that underlying logic that connects everything.
Okay, so if AI is struggling even with all the data in the world, at least for certain math problems, what's the answer? Do we just keep feeding it more and more data? Or is there something more to it than that?
That's the million-dollar question, isn't it? And that's where this Omni-MATH thing, it gets really, really interesting.
It's like, you know, when you're trying to teach someone to cook,
Okay.
you can give them all the recipes in the world, right? Mountains of them.
Yeah.
But until they understand those flavors, how those flavors work together, the why behind the recipe,
Right.
they're not going to be winning any cooking competitions anytime soon.
It's a great analogy, actually. And it gets right to the heart of what these researchers are wrestling with. It's not just about data, data, data. They're developing these new training methods specifically to try to build those skills in AI logical reasoning, problem solving, almost like a digital tutor guiding them through those aha moments, you know.
So less about memorizing the equations, more about understanding how to approach a problem, like from the ground up.
Exactly.
That makes sense, but
Yeah.
how do you even begin to teach a machine those kinds of skills? It's not like you can just, you know, hand it a logic puzzle book and say, go have at it, figure this out.
You're right. It is a fascinating challenge, though.
Yeah.
One approach they're trying is to give the AI these step-by-step solutions to problems.
Okay.
And then they ask it to actually explain the reasoning behind each step.
Interesting.
It's almost like, you know, in math class when you had to show your work.
Right.
So the teacher knew you didn't just copy the answer from your neighbor.
Exactly.
Exactly.
Learning by explaining, that's a really cool concept. But it makes you wonder, if we're trying to make AI think more like us, could this research actually teach us something new about how we learn?
That's the really exciting part, I think. It's a two-way street.
Yeah.
By studying how AI learns, we might actually stumble upon new insights into our own learning process, the human learning process.
Fascinating.
It's like holding a mirror up to our own cognition.
Okay, now that is a deep dive if I've ever heard one. But before we get too lost in the, you know, philosophical implications of it all, let's bring it back down to earth for a second, back to Omni-MATH. We talked about AI's struggles, the efforts to improve it. How do we even go about measuring its progress? Is there like an AI set out there somewhere?
Well, there's something even more interesting, I think. Remember we were talking about how AI has a hard time grasping the why behind the math?
Right.
To deal with that, researchers are actually building a system called Omni-Judge.
Omni-Judge. Okay, that sounds intense.
Yeah.
What is that?
Basically, it's an AI that grades other AI's math homework.
Whoa.
And it goes way beyond just checking if they got the right answer. Omni-Judge, it's designed to assess the quality, the logic behind those AI-generated solutions, almost like, you know, a human expert would.
Wow. So AI is checking AI's work now. It's like a robotic peer review session. But how do we know if Omni-Judge is even accurate? What's the benchmark there?
That's where it gets really, really interesting. They tested Omni-Judge by comparing its assessments to those of human math experts.
Okay.
And get this, they found that Omni-Judge, even though it's still under development, showed around 86% agreement with human judgment.
86%. That's incredibly high. It seems like AI is making some serious headway in the world of, super advanced mathematics after all.
Oh.
But what about those limitations we talked about before? What are researchers doing to try to help AI clear those hurdles, especially when it comes to, things like discrete math?
So one approach is, of course, feeding it more data,
Yeah.
particularly in those areas where it's struggling.
Yeah.
But it's not just about quantity, right? It's about the quality, the structure of that data.
Okay.
They're working on refining the data itself, making sure it's organized in a way that AI can learn from more effectively.
Makes sense.
Think about it this way. If you're teaching someone a new language, you wouldn't just throw a dictionary at them.
Right. Of course not.
Right. You give them structured lessons, grammar rules, conversational practice.
Context is key. You need those building blocks to really grasp a new language or a new, area of math in this case.
Exactly.
Yeah.
And that's what makes this whole research area so fascinating. It's not just about, building a smarter AI. It's about understanding how to optimize its learning process.
Right.
And here's another interesting thing they found. When they trained the AI models on more challenging math problems,
Yeah.
it actually boosted their performance on easier problems, too.
It's like saying if you can climb Mount Everest, hiking up a hill is a piece of cake.
Exactly. Precisely. And this suggests that maybe, just maybe, there are these fundamental principles of mathematical reasoning that AI can grasp. And then those principles can be applied across different levels of difficulty.
So it's not just about teaching AI to solve specific problems. It's about unlocking a deeper understanding of math itself.
That's the ultimate goal.
Wow.
And it's a goal with potentially massive implications.
I mean, imagine AI that could help us solve these really complex problems in medicine, engineering, or even predicting the stock market.
Absolutely.
The possibilities are kind of mind-blowing when you think about it.
It really is. We're talking about potentially revolutionizing entire fields. I mean, leveraging AI's growing mathematical prowess.
So it's not just about the AI becoming these, mathletes.
Right.
It's about them becoming this incredible tool to solve these real-world problems, these things that have, stumped us for centuries.
Exactly. And that's what I think makes this whole area of research so compelling. It's not just an academic exercise, This has the potential to really, reshape our world.
It really does. It's like we're standing at the edge of, this whole new era of, discovery and innovation. And AI is unlocking the door for us. This has been an amazing, amazing journey. What stands out to you the most from all of this?
For me, I think it's that idea of AI potentially teaching us something new about how our own brains learn. It's like the student becoming the teacher.
It is. It's fascinating, isn't it, that we might gain these new insights into ourselves through the process of building these incredibly complex machines.
Well, on that note, I think it's time for us to wrap up this deep dive. A huge thank you to you, expert speaker, for joining me today and sharing your insights. And to all our listeners, thank you for exploring with us. We'll see you in our next deep dive. Take care. Hey there, learner. Buckle up, because today's deep dive is all about the quest to build an AI that can conquer Olympiad-level math. We're talking those brain-melting problems that make even seasoned mathematicians sweat. We're dissecting a mountain of cutting-edge research, and trust me, the findings are seriously mind-blowing. Thankfully, I've got expert speaker here to help us navigate this complex landscape. They've got this amazing knack for spotting the patterns and connections that make everything click. Ready to dive in?
Let's do it. I'm always up for a good mathematical challenge.
All right, so we've all heard about AI's recent triumphs in fields like chess and Go. And yeah, AI can even crush it in calculus now. But here's the thing. The benchmarks we've been using to measure AI's mathematical prowess are starting to look a bit like baby steps.
That's right. Existing benchmarks like GSM-8K and Math, while impressive in their own right, are no longer sufficient to truly challenge these advanced models. We're seeing scores in the 90th percentile, which might seem like AI has already arrived, but it's a bit like saying a child who's mastered their multiplication tables is ready for the International Math Olympiad. There's a whole universe of mathematical complexity beyond those basic operations.
Okay, I'm starting to see the problem. We're giving these AI models a pop quiz when they need to be prepping for, the mathematical equivalent of the Ironman competition.
Exactly. And that's where Omni-MATH comes in. This new benchmark, designed to really push the boundaries of AI's mathematical abilities, is a collection of 4,428 competition-level problems that mirror the challenges faced in prestigious math Olympiads.
As someone who barely scraped by in high school algebra, even the name Omni-MATH sounds intimidating. So we're not just talking about solving for X anymore. What kind of problems are we talking about here?
We're talking about the kind of problems that require deep conceptual understanding across 33 distinct mathematical domains, from linear algebra to abstract algebra and beyond. It's not just about applying formulas, but about demonstrating true mathematical reasoning, the ability to analyze, synthesize, and strategize.
Wow, okay, I'm officially out of my depth here. But I'm guessing these Olympiad-level problems are carefully chosen for a reason.
Absolutely. Each problem in Omni-MATH is categorized not only by its domain, but also ranked on a difficulty scale that spans from introductory to professional international competition levels. This allows researchers to pinpoint exactly where AI excels and where it stumbles, offering valuable insights into the strengths and weaknesses of different models.
So it's like a highly specialized training montage for AI mathematicians.
You could say that. And just like in those montages where the hero faces setbacks and learns from their mistakes, the results of this study revealed some humbling truths about the current state of AI in math.
You're saying even the AI MVPs fumbled the ball on this one. Give us the play-by-play.
Even the most advanced models, the ones considered to be at the forefront of AI mathematical reasoning, struggled to keep up. OpenAI's model, for example, only achieved about 60% accuracy on Omni-MATH.
60%. That's a far cry from those A-plus scores they were racking up on the easier benchmarks. So what does this tell us? Are we about to hit a wall in AI development when it comes to math?
Not necessarily. It's more nuanced than that. This research isn't about declaring AI a failure in math. It's about recognizing that the current generation of AI models,
All right.
while incredibly powerful,
Yeah.
still lack certain fundamental capabilities that human mathematicians possess.
So it's less about AI hitting a wall and more about us realizing we're still climbing the mountain.
Precisely. Think of it this way. Even within this study, there's a spectrum of AI models, each with its own strengths and weaknesses. And what's fascinating is that these strengths and weaknesses don't always align with how we, as humans, perceive mathematical difficulty.
You've really piqued my curiosity here. Tell me more about these unexpected patterns.
Take the concept of difficulty consistency, for example.
Okay.
You'd assume that if an AI can solve a fiendishly complex Olympiad-level problem,
Right.
it should breeze through a simpler, more elementary one, right?
That seems logical. You don't see many people acing advanced calculus while struggling with basic algebra.
And yet, that's exactly what the researchers observed. Some AI models exhibited this strange inconsistency, solving problems that human mathematicians would consider incredibly difficult while stumbling on seemingly straightforward ones.
So what's going on there? Is this like some kind of AI glitch in the matrix?
It's more about the fundamental differences in how AI and humans approach problem solving. Humans learn math incrementally, building a foundational understanding of core concepts and then layering on more complex knowledge.
Like building a house, you need a solid foundation before you can add the roof.
Exactly. But AI doesn't always learn in this linear fashion. Depending on the training data and methods used, an AI model might develop highly specialized skills in one particular area without necessarily grasping the underlying principles that connect different mathematical concepts.
So it's like the AI has memorized a set of dance moves without truly understanding the rhythm or the music.
A great analogy. And this lack of deep understanding can trick them up when faced with problems that require a more flexible, adaptable approach.
This makes me think about those moments when you're so focused on a particular solution path that you miss a more elegant or efficient approach. Is that something AI might struggle with?
It's a possibility. One of the key takeaways from this research is that simply exposing AI models to massive amounts of data isn't enough to cultivate true mathematical reasoning. We need to find ways to teach AI not just what to think, but how to think.
We've got to bridge that gap between calculation and comprehension.
Right. It's about developing AI systems that can not only crunch numbers, but also understand the underlying principles, make connections, and even exercise a degree of creativity in their problem solving.
That's a tall order. This Omni-MATH study feels like a real wake-up call for the field of AI. What are some of the most promising avenues for moving forward? Where do we go from here? Okay, so we've learned about AI struggles with Olympiad-level math. We've explored the concept of difficulty consistency, where AI models sometimes fail on simpler problems after conquering the most challenging ones. But before we get too philosophical, let's take a closer look at the tools that researchers are developing to address these challenges. Remember, Omni-Judge.
That's right. Omni-Judge is a fascinating development, and it speaks to the growing sophistication of AI evaluation methods. It goes beyond simply checking whether the AI model got the right answer. It analyzes the step-by-step reasoning process, uncovering those hidden patterns and potential blind spots that might otherwise go unnoticed.
So it's like an AI-powered tutor, not just a grader. It can actually pinpoint where an AI model might be going astray in its reasoning and offer guidance for improvement.
You could say that. What's really remarkable is that Omni-Judge has demonstrated a surprising consistency with human judgment when it comes to evaluating complex mathematical problems.
This is huge because it means that AI itself can now be used to streamline the process of evaluating other AI models. That could drastically speed up the research and development process,
Yeah,
right?
absolutely.
Yeah.
Imagine being able to train AI on these challenging problems without having to rely on a team of mathematicians to manually grade each attempt.
Yeah.
It opens up the possibility of scaling up AI research in ways that were previously unimaginable.
Okay, so we're talking about a real game changer here,
Yeah.
but what are the implications beyond simply making the evaluation process more efficient? What does this tell us about the future of AI in math?
This is where things get really interesting. This research tells us that the future of AI and math isn't just about churning out more and more powerful algorithms. It's about a deeper understanding of the learning process itself. How can we teach AI to think more like humans to develop that intuitive understanding of mathematical principles?
You're saying we need to build AI that can learn and reason, not just calculate.
Precisely. We're still on the first page of that textbook, but we're starting to see the potential for AI to make a real difference in how we explore and understand the world around us.
And who knows, maybe one day we'll see an AI model that can actually outthink a human mathematician. But before we get carried away with that, we need to consider the bigger picture. What are some of the key takeaways from this research that you hope our listeners will walk away with?
First and foremost, I want listeners to appreciate the complexity and nuance of AI research, especially in a field like mathematics. It's not just about finding solutions, it's about understanding the limitations of existing systems and developing new methods for addressing those challenges.
Absolutely. And it's important to remember that AI is constantly evolving. What might be an insurmountable challenge today could be a routine task tomorrow.
That's the beauty of this field. It's always pushing us to expand our horizons and question our assumptions.
It's a humbling reminder that the journey of AI is just beginning. We've covered a lot of ground today, from the struggles of AI with Olympiad-level problems to the emergence of tools like Omni-Judge that are paving a way for future breakthroughs.
And as we continue to explore the intersection of AI and mathematics, we're bound to uncover even more surprises and insights.
So what do you think, listener? Does the idea of an AI that can master Olympiad-level math fill you with excitement, trepidation, or a healthy mix of both? We'd love to hear your thoughts. This has been a deep dive into the cutting edge of AI and mathematics. Until next time. Ever wonder how we'll know when AI is truly smart?
Yeah.
Like not just winning at chess, but actually, thinking on a human level.
Yeah, that's the question, isn't it? It's like, how do you actually measure something as complex as intelligence, especially when it comes to AI?
Well, that's exactly what this whole deep dive is about. We're going to be diving into how AI measures up against, get this, Olympiad-level math.
That's right, Olympiad level. We're talking about the research paper, Omni-MATH, a universal Olympiad-level mathematic benchmark for large language models. Basically, they created this crazy hard benchmark to see if AI can actually understand and solve, like, really, really hard math problems.
And let me tell you, even just skimming through this paper, I felt my brain starting to hurt a little bit. We're talking about competitions like the International Mathematical Olympiad, the Putnam,
Yeah, those are intense.
like the kind of stuff that would make even a math professor nervous.
Absolutely. And that's the whole point. See, AI has actually gotten so good at math that the old benchmarks they used, things like GSMAK and math, those are starting to feel like, well, kids stuff for these super advanced AI models.
So time to up the ante, right?
Exactly. They had to make it harder, crank it up to 11, to really see what these AI models are capable of.
So they weren't just pulling from the big famous competitions, were they?
Oh, no. This research actually looked at a ton of different Olympiad-level math competitions, some of them I had never even heard of.
Really?
Oh, yeah. They were all carefully chosen, though, and ranked by difficulty to create this, like, ultimate math showdown.
It's almost like they created the most intense math competition in history.
Yeah.
And then they decided to invite AI to the party.
Uh-huh. That's a good way to put it. And it wasn't just one type of AI either. They tested a whole bunch of different large language models, different designs, different training data, even comparing the big expensive ones from companies like Google and OpenAI to the open source models that, anyone can use.
Is that like a fair fight? Open source versus the big dogs?
That's a really important question, and this research actually looks into that. By including both types of models, we get a much better idea of where AI development is at, like across the board. And the results, well, they're pretty interesting, to say the least.
Okay, before we get to those results, I got to ask why math? I mean, there are a lot of other complex things AI could be tackling.
Well, Olympiad-level math is kind of special. It's not just about doing calculations. It's about logic, abstract thinking, that aha moment of insight.
Right, like those creative problem-solving skills.
Exactly. And those are things that even the most powerful computers have historically struggled with.
So it's like a test of true understanding, not just number crunching.
That's a good way to put it. And to make things even more interesting, the researchers didn't just lump all the math problems together into one giant test. They actually organized them into over 33 different subdomains of mathematics.
Hold on, 33. Are there really 33 different types of algebra?
Haha. It's more like 33 different areas within mathematics, each with its own rules and challenges. You've got everything from algebra and calculus to things like discrete mathematics, number theory, even non-Euclidean geometry.
Okay, you lost me at non-Euclidean geometry. But I'm guessing there's a reason for all this mathematical madness.
Of course there is. By separating the problems like this, they could see how well AI did in each specific area. It's like giving an athlete a decathlon instead of just a 100-meter dash.
Right, you get a much better picture of their strengths and weaknesses.
That's exactly it. Yeah, it's like they're trying to figure out not just what AI is good at, but also where does it kind of stumble. And those weak spots, those can actually tell us a lot about how AI learns and what we need to work on.
It's like taking AI to a therapist, right? Tell me where it hurts.
Exactly. And one area where AI seems to be feeling the burn is this thing called discrete mathematics.
Discrete mathematics. Remind me again, what was that one?
So it's basically a branch of math that deals with like separate values instead of continuous ranges. Imagine things like networks, algorithms, logic puzzles, that sort of thing.
Okay, so less about smooth curves and more about connecting the dots, right?
You got it. And here's the thing. AI seems to find this type of math way harder than something like calculus or algebra. Even the AI models that were acing everything else, they really struggled to get good scores on the discrete math part of this whole Omni-MATH challenge.
Why do you think that is? Is it just that, like, the AI hasn't seen enough examples of these types of problems?
That's definitely possible. Maybe they just need more practice. Or it could be that discrete mathematics requires a different kind of thinking, It's less about recognizing patterns, which AI is really good at, and more about that abstract reasoning.
Interesting. So it's still a bit of a mystery.
It is, and that's what makes this research so cool. It's not just about testing AI. It's about trying to understand how mathematical thinking works, both for humans and for machines.
All right, well, now I got to know, how did these AI models actually do? Give me the scores.
Get ready for this because it's a wild ride. The AI that scored the highest was OpenAI's model, the O1 Mini, and it got about a 60% on the entire Omni-MATH benchmark.
60%. Honestly, I was expecting a bit more, considering it's supposed to be the best of the best.
Yeah, but keep in mind, we're talking about Olympiad-level stuff here. These are the kinds of problems that make even experienced mathematicians sweat a little bit.
That's true. I guess the 60% on this is still pretty good. But that was the top score, right? What about everyone else?
This is where it gets really interesting. So some of those open source AI models, the ones that anyone can use, some of those actually did better than some of the bigger, more expensive models from the big tech companies.
Wait, seriously? So it's like David versus Goliath, but with AI and math problems?
Exactly. And that's a really exciting thing to see because it means that AI development isn't just limited to these giant corporations with tons of money. Those open source models, they're proving that they can keep up even on the really tough challenges.
I love that. Okay, so we've got AI failing Olympic-level math, which is honestly a little reassuring, and we've got these underdog AIs going head-to-head with the big guys. What else did this research dig into?
Well, there's one more thing we should probably talk about, and it's kind of unexpected. Remember how we were talking about how hard it is to actually grade AI on these super complicated math problems?
Yeah, it's not like you can just use a calculator, right?
Exactly. So how do you even begin to evaluate an AI on something designed for, like, the smartest mathematical minds out there?
Okay, I'm hooked. How'd they do it?
They used another AI.
Wait, what?
Yep, they used GPT-4, one of the most advanced AI systems we have right now.
Hold on. They used an AI to grade other AIs. That seems a little circular. Like, how do we know the grading was unbiased? Okay, so they used an AI to grade other AIs on Olympic-level math, and that's supposed to tell us something. How can we be sure that's even accurate?
Well, it's not as crazy as it sounds. With these kinds of problems, it's not just about getting the right answer. It's about the process, the logic, even the creativity of the solution.
So they needed a judge that could, like, understand the elegance of a good proof, not just look at the final answer.
You got it. It's kind of like judging figure skating. You need someone who gets the artistry. Plus, we're talking about problems that even human mathematicians might disagree on, so it's not always clear-cut.
But how do I know GPT-4 was being fair? Did they have, like, actual mathematicians double-check its work?
They did. They compared GPT-4's grading with human experts and found that they agreed a whopping 98% of the time.
Wow, that's actually really impressive.
Yeah.
So maybe AI can be a good judge of math, at least sometimes.
It seems that way, and it opens up some interesting questions for the future, like, will we see more of this AI judging AI thing as these systems get even more advanced?
It's kind of a mind-blowing idea.
Yeah.
But taking a step back, what does this all actually mean? Like, should we be worried that AI is going to be winning Fields medals anytime soon?
I think we're safe for now. This research is more about where AI is at right now, how it tackles these really complex problems. The fact that it struggled with some types of math, like that discrete math we were talking about, tells us it still has a ways to go.
So it's less about AI replacing mathematicians and more about AI giving us new tools and insights into those really tough problems.
Exactly. It's about using AI to help us push the boundaries of what we know.
Yeah.
Imagine having a calculator that could not only give you the answer, but also explain how it got there in a way that even we can understand.
That would be pretty amazing. What about those open source models that were going toe-to-toe with the big corporate AIs? What does that tell us?
I think it points to a future where AI development is more open, more collaborative. It's not just a race between a few giant companies anymore. It's everyone working together to see what's possible.
I like the sound of that. So to wrap things up, we've talked about how researchers are using these insanely hard math problems to figure out how AI thinks, how surprisingly good AI can be at grading other AI, and how this whole field is becoming more open and accessible.
It's a really exciting time to be following this stuff.
It really is. So for our listeners out there, here's something to think about. If AI can take on the toughest math problems in the world, what challenge are you going to tackle today? Keep those brains buzzing, and we'll catch you next time. Okay, so get this. AI solving math problems, right? But we're not talking like your kid's homework here. We're talking like serious college-level math. It's kind of blowing my mind how good they're getting.
Yeah, it's seriously impressive. I mean, we're talking near perfect scores on these benchmarks like GSM-8K and math. These are tests that honestly would make most people sweat, you know?
No kidding, I would be totally lost.
Yeah.
But it really gets you thinking, how far can they actually go with this? Like, can AI tackle the really hard stuff, the kind of problems that math Olympiad champions eat for breakfast?
And that is the million-dollar question, and that's where this new research comes in. They've introduced this new benchmark called Omni-MATH. It's specifically designed to test AI at, that Olympiad level of difficulty.
So we're talking about like a whole other league of math here, right?
Exactly. I mean, picture this, a data set of 4,428 competition-level math problems. It's like the ultimate test of mathematical prowess.
Wow, 4,428. Okay, so that's a lot of math problems. But it's not just about crunching numbers, right?
Right. It's way more than that. What makes Omni-MATH really interesting is it focuses on text-only problems. So the AI has to actually understand the language of mathematics, not just recognize patterns.
So it's less about memorizing formulas and more about like actual problem solving.
Exactly. They have to read the problem, understand the logic, come up with a strategy.
Wow, so it's almost like what a human would do.
Exactly, just like a human competitor in a math Olympiad.
Okay, so they're not messing around here, huh?
Yeah.
They pulled out all the stops to make this thing challenging.
Oh, absolutely. And to ensure the AI is facing a real challenge, they didn't just like make up problems. They actually sourced these problems from real Olympiad
Oh,
competitions.
wow. So these are legit, like, the same problems that those math whiz kids are tackling.
You got it. And to make things even more interesting, to make sure everything is super rigorous, they had professional mathematicians verify every single problem and solution.
So we've got a panel of math experts making sure this thing is the real deal. That's pretty intense. But it gets even more interesting, right? Because they didn't just, like, throw all these problems into one giant pile.
Oh, no, no, no. They got way more organized than that.
Okay, good, because I was starting to get a little overwhelmed.
They broke down these thousands of problems into 33 different subdomains of mathematics. We're talking algebra, geometry, number theory, you name it, it's in there.
So it's like they created a whole map of mathematics and then designed problems for every single stop along the way.
Exactly. And if that wasn't enough, they also categorized each problem into 10 levels of difficulty.
Oh man, they really thought of everything.
They had to. This structure is super important because it allows researchers to see exactly where AI excels and where it stumbles.
Okay, so we've got this crazy challenging benchmark, a massive data set of Olympiad-level problems, and a clever way to analyze the results. But how did the AI actually do? Did they rise to the challenge or did they totally crack under pressure? We'll find out as we continue our deep dive. All right, so spill the beans. How'd those AI models do against the Olympiad problems?
Well, let's just say those Olympiad problems really separated the AI wheat from the chaff.
Oh, so even the ones that were like acing those easier benchmarks, they struggle on this.
Yeah, even the top performers, the ones that were, getting near perfect scores before, they definitely felt the heat with Omni-MATH.
Okay, so how much did their performance actually drop? Give me the numbers.
All right, so let's take OpenAI's O1 Mini, for example. This is considered one of the leading models out there, right?
Okay.
On Omni-MATH, it got an accuracy of 60.54%.
Okay.
Which, might sound decent at first glance, but remember, this is a model that was practically perfect on those simpler tests.
Yeah, 60% is a far cry from 100%, that's for sure. I guess it really highlights the difference between, like, regular math problems and those crazy Olympiad ones.
It's a whole other ballgame.
Okay, so the O1 Mini took a bit of a tumble. What about the other OpenAI model, the O1 Preview?
Yeah, so that one actually clocked in a little lower at 52.55% accuracy.
Interesting. So even with different approaches, those top-tier models, they were still, struggling a bit. What about the open source models? Did they manage to catch up at all?
Well, the top performer in the open source category was Quan 2.5 Math. It reached an accuracy of 36.2%.
Okay, so not quite at the same level as the big dogs yet, but still.
Not too shabby, right?
I mean, 36% on Olympiad-level math problems, that's got to count for something.
Right. It's definitely impressive, especially when you consider the resources and data available.
Okay, so we've talked about their overall performance, but I'm really curious to dig into those subdomain results. Because Omni-MATH, it breaks those problems down into different areas of math.
Right, and that's where it gets really interesting. It's not just about the overall score, it's about understanding the nuances of what they're good at and what they struggle with.
Exactly, like, are there certain types of math that AI is just naturally better at?
Well, that's what they wanted to find out, and there were definitely some patterns that emerged.
Okay, like what? Spill the tea.
All right, so one thing that was really clear is that AI models, they seem to have a knack for algebra, calculus, and number theory.
Interesting.
Those areas, it turns out, they have tons of training data available. So it makes sense that the AI would perform well in those areas, right?
Totally. It's like anything else, the more you practice, the better you get,
Yeah.
even if you're an AI.
Exactly. But here's the twist. AI seems to really struggle with discrete mathematics.
Discrete mathematics.
Yeah, this includes things like graph theory and combinatorics.
Okay.
And it seems to be their Achilles heel.
Really? So it's like they can ace their algebra test, but then they completely blank on the geometry proof. Why is that? Any theories?
Well, one thought is that there's just not as much training data available in discrete mathematics compared to other areas. It's like trying to learn a new language, but you've only got a handful of sentences to work with.
Yeah, that makes sense. You need a lot of data to really train these AI models.
Exactly. And so that's actually really valuable information for researchers.
How so?
Well, now they know where to focus their efforts, right? They can develop more targeted training techniques or even tweak existing ones to specifically address those areas where AI is lagging behind.
It's like giving them a roadmap for improvement.
Hmm.
Okay, so we talk about AI's strengths, their weaknesses, but I'm wondering, are there any, like, fundamental limitations to the techniques they're using. Is there something about how they're approaching the problems that might be holding them back at this, like, really high Olympiad level?
That's a great question, and it brings us to a really interesting concept in AI research. Best of N.
Best of N. Okay, you're going to have to break that one down for me.
Okay, so imagine you've got your AI model, and it's trying to solve this super difficult math problem, right?
Okay.
With Best of N, what you do is you basically have the AI tackle the problem multiple times.
Oh, interesting.
But each time, it uses slightly different parameters or starting points.
So it's like giving the AI multiple attempts at the problem,
Well,
hoping that one of those attempts will, hit the jackpot.
exactly. It's like giving the AI a set of tools and seeing which combination unlocks the solution.
Okay, I'm following you.
Now, this technique has been really effective for a whole bunch of AI tasks. But here's the thing. It didn't seem to make a huge difference with these Olympiad-level math problems.
Really?
Yeah.
So even with, like, multiple tries, they were still hitting the wall.
Yeah, which suggests that we might need entirely new approaches, like completely different techniques, if we really want to boost AI's reasoning and problem-solving abilities at this advanced level.
So it's not just about giving them more data or more processing power. It's about teaching them to think differently.
Exactly, more like a human mathematician would.
That's fascinating. Okay, so where do we go from here? What's the next step in this AI math odyssey? We'll tackle those mind-blowing questions in the final part of our deep dive. Okay, so we've seen what AI can do, we've seen where it struggles, but the big question is, where do we go from here?
Right. What does the future hold for AI in the world of really high-level math?
Could you even imagine, like, an AI actually winning a Fields Medal someday?
Well, I mean, never say never, right?
Yeah.
But it really begs the question, will we ever see AI consistently solving these crazy hard math problems, like going head-to-head with the best human mathematicians and actually coming out on top?
It's a wild thought, isn't it? Because we're not just talking about an AI that can, like, crunch numbers really fast. We're talking about an AI that truly understands the beauty, the elegance of a complex proof.
Exactly. And that's like a whole other level of intelligence.
It really is. But even if they never reach, like, human-level genius, think of all the cool stuff that we could learn along the way.
Oh, absolutely. I mean, imagine the insights these AI systems could uncover, the new mathematical tools, the problem-solving strategies. It could totally revolutionize how we approach math.
It's like giving mathematicians a superpower.
Right. Augmenting human ingenuity, not replacing it.
I like that. So, okay, let's say we want to make this happen. We want to bridge that gap between where AI is now and, like, total Olympiad-level mastery.
It's a huge challenge, but that's what makes it so exciting.
What's the missing piece of the puzzle? Is it just more data? Or do we need to, like, fundamentally rethink how we design these AI brains?
I think it's probably a combination of things. Like, we might need to rethink the very architecture of AI models.
Okay, so, like, start from scratch almost.
Well, maybe not completely from scratch, but definitely a radical rethink. We need to go beyond the current approaches, build systems that are specifically designed for abstract reasoning, for symbolic manipulation, the really high-level stuff that makes advanced math so difficult.
So it's like teaching AI a whole new language, one that's closer to pure mathematics than just, like, translating back and forth from code.
Exactly. And there's also that element of creativity, of intuition, that's so crucial to how mathematicians work. Can we teach an AI to appreciate the elegance of a proof, the thrill of discovery?
Whoa! Teaching an AI to find joy in problem solving. That's next level stuff. But it makes you wonder, what if mastering math at this level is actually the key to something even bigger?
Now you're thinking.
Like, could it unlock new levels of AI capability across the board?
Right, because math, it's often seen as the purest form of reasoning. It's a way to understand the fundamental structure of the universe.
So if AI can truly grasp that,
who knows what other doors that could open?
it's a bit mind-blowing when you think about it.
Yeah.
Like, a bit exciting, but also a tad scary.
Oh, definitely.
But one thing's for sure, we are living in a pretty amazing time for AI.
Absolutely. Every challenge we overcome, every milestone, it brings us closer to unlocking the full potential of these systems.
And who knows, maybe along the way, we'll even learn a thing or two about our own intelligence.
It's all connected, right?
Exactly. Well, this deep dive has been a wild ride. We've talked about AI, math, the nature of intelligence has been quite the journey, and we hope you've enjoyed it as much as we have. Thanks for listening.